A crisp apple. Sweet. Are fibrous. A symbol of healthy living. Doctors recommend eating one daily. Supermarkets stack them into glowing red pyramids. Yet inside the small, often forgotten core lies a compound that laboratories classify among substances capable of causing death at high doses: cyanide. The contradiction sits right in your hand. The fruit that represents wellness also carries a chemical defense system sophisticated enough to earn its own chapter in medical textbooks. There is no need for panic. This story is not meant to turn your snack into a crime scene. What matters is understanding that nature did not design fruit to serve humans. Apples do not exist to be sliced into salads. They exist to reproduce. And to protect the seeds, the only part truly essential to the tree nature installed what could be described as a biological minefield. From here, the question shifts direction. Why would an apple tree need cyanide? And how does this mechanism work at the molecular level? Apple seeds contain a compound called amygdalin, a member of the cyanogenic glycoside family. Its structure consists of a sugar component bound to a group capable of releasing cyanide when broken down. If you swallow a seed whole, its tough outer shell usually passes through the digestive system with little release of toxins. But when the seed is crushed, enzymes within the plant tissue come into contact with amygdalin and begin a process called hydrolysis. This reaction releases hydrogen cyanide, a gas that can interfere with cellular respiration. Numbers make the picture clearer. One apple seed contains roughly 0.0 milligrams of amygdalin. Reaching an acutely dangerous level for an adult would require consuming the equivalent of hundreds of thoroughly crushed seeds. This does not make cyanide harmless. It simply shows that the system evolved primarily to deter small animals, mice, or squirrels weighing a few hundred grams, not a 60-kilogram human. From an evolutionary standpoint, the strategy makes sense. The sweet flesh attracts animals to eat the fruit and disperse the seeds. The hard seed casing contains toxins to discourage chewing. Nature assigns roles clearly. Eat the fruit. Leave the seeds intact. This balance has sustained the apple's reproductive cycle for millions of years. The story becomes even more interesting when viewed more broadly. Apples are not unique. Bitter almonds, apricots, peaches, cassava, and even cherry pits contain similar compounds. Cyanide is not a chemical accident. It is a recurring design pattern in the plant kingdom. Then comes a detail that often makes people pause. Cyanide smells like almonds. Hydrogen cyanide is described as having a bitter almond scent. However, not everyone can detect it. About 40% of the population lacks the specific olfactory receptors needed to recognize this smell. Two people standing next to the same source of cyanide may have completely different sensory experiences. This is not mystery, it is genetics. Our brains interpret smells as signals, either warning or attraction. Sweet almonds evoke food, desserts, flavorings. Cyanide happens to share part of that scent profile. There is no intentional deception. The molecule simply interacts with smell receptors in a way similar to certain compounds found in almonds. Why would plants produce a compound with a scent that is not strongly unpleasant? Because the goal is not to warn humans. The goal is to trigger a physiological reaction in animals that consume the seeds. When cyanide is released inside the digestive system of a small animal, it inhibits an enzyme called cytochrome C oxidase in the mitochondria. Mitochondria are the cell's power plants, where oxygen is used to produce ATP, the molecule that fuels life. When this enzyme is blocked, cells cannot use oxygen even though oxygen is present in the bloodstream. The result is oxygen deprivation at the cellular level. In a 200-gram rodent, a small dose can cause serious harm. In a 60-kilogram human, the same mechanism rarely reaches dangerous levels from just a few apple seeds. Differences in body mass and dosage create two entirely different biological outcomes. From the almond scent, the story moves to a deeper question. If cyanide is so dangerous, why can the human body tolerate small amounts without issue? The liver contains an enzyme called rhodinase, which converts cyanide into thiocyanate, a far less toxic compound that is excreted in urine. This detoxification process works efficiently at low doses, similar to how the body processes moderate amounts of alcohol. This explains why eating apples throughout your life does not send you to the emergency room. However, detoxification has limits. When cyanide intake exceeds the body's capacity to convert it, blood levels rise rapidly. The heart and brain organs that require the most oxygen are affected first. The process unfolds in minutes, not hours. That speed is why cyanide appears frequently in toxicology training programs. The coexistence of sweetness and toxicity within the same fruit offers a lesson in natural design. The most appealing part lies on the outside. The most protected part lies within. Humans learn to eat the flesh and discard the core, not because of warning labels, but because culinary traditions accumulated experience over time. Seen more broadly, cyanide in apple seeds is not a conspiracy against humanity. It is the result of an evolutionary arms race between plants and herbivores. Trees need to protect their seeds. Animals need energy. The outcome is a balanced system. Edible flesh encourages cooperation, while toxic seeds set boundaries. From the apple core, another thought emerges. Each bite of an apple places you inside an evolutionary agreement, millions of years in the making. You receive sugar and vitamin C. The tree receives seed dispersal. The only condition is simple. Do not destroy the genetic archive inside the seed. The next time you eat an apple, you might pause for a few seconds before discarding the core. Not out of fear, but out of curiosity. Even the most familiar foods carry a hidden chemical story. And if quiet defense systems like this spark your interest, there are many more places in nature where intricate mechanisms are hidden in things even smaller than an apple seed.